we're going to find the vertex of this quadratic equation right here. The formula that we use is negative b divided by 2a. That's going to give us the x coordinate. So let's find the x coordinate of the vertex. This is A, this is B, and this is C. So your B value is -9. You guys see that? So I'm going to erase B and put a -9. I'm going to erase A and put a 2. Okay, 2 negatives make a positive. So this will become a +9 over 2 times 2 is 4. So that is the x value of my vertex. If you don't want to put 9 over 4, you can use your calculator. What is 9 divided by 4? Exactly, 2.25. So you can also put the 2.25 instead of a fraction. Now, how do I find the y value of my vertex? You plug this in. Okay, so I'm going to write this out. This is my equation. And I'm going to plug in 2.25. All right, guys, go ahead and calculate that in your calculator. Perfect. Okay, so we got -6.125 for the y value of the vertex. Okay, so I'm going to go ahead and plot that. This is 1, 2, 3, so 2.5 is somewhere in between there, and -1, 2, 3, 4, 5, 6. I'll be right here somewhere. That is my vertex. Everyone plot the vertex. Your vertex is at 2.25 and -6.125. This is your vertex. Now, guys, looking at the equation, should I draw my graph like this, or should I draw it facing down? Why am I going to draw it up? Yep, your A value is positive. There's a positive in the very front. So I know it's going to be facing up. Okay, so now let's find the y-intercept. How do we find the y-intercept? Yep, you're going to plug in zeros. Everyone write that down. Plug in zeros. Let me just give you a hint. It's always going to be this C value. Because if you plug in a 0 right here, 0 squared is 0 times 2 is 0. That's gone. 9 times 0 is 0. That's gone. You're left with 4. So your y-intercept is 0, 4. It's basically your C value. Okay, now the x-intercept. You guys can use 2 different methods here. You can factor and figure out what your x-intercepts are, or you can use the quadratic formula. We're going to be using the quadratic formula a lot this unit, so I'll just go ahead and do the quadratic formula. Okay? But you can use either or. The quadratic formula will always work. So let's do the quadratic formula. The formula is x equals -b plus or minus square root b squared minus 4 times a times c all over 2a. And we're just going to plug in the values. So I know my b value is -9. My a value is 2. And my c value is 4. Okay. These 2 negatives make a positive. -9 squared is 81 minus 4 times 2 is 8 times 4 is 32 all over 4. Okay, what's 81 minus 32? Good, 49. So this becomes the square root of 49. Guys, do you know what the square root of 49 is? 7? Perfect. Let me replace this. Let me just put a 7. Okay, so those are my 2 answers. Let me highlight it for you. Think about what is 9 plus 7. Can someone tell me that? 16. divided by 4. 4, so that's one of my answers. One of my x-intercepts is 4, so I'll put 4, 0. And I'm going to have a second one. Let me highlight again for you so you know what we're looking at. Now I'm going to do the subtraction this time. Now, what is 9 minus 7? 2 divided by 4? Exactly. So you'll get 2 over 4. You can write it as 1/2 or 0.5. Either or works. So I'll just put a half. So those are my 2 x-intercepts. So go ahead and graph that. A half is between 0 and 1, so right there. My other x-intercept is at 4, right there. And my y-intercept is 1, 2, 3, 4, right here. Okay, so guys, go ahead and finish your graph. We have our y-intercept, our x-intercepts, and our vertex. Okay, now let's talk about the axis of symmetry. Where do you think the axis of symmetry is? Exactly, it's at 2.25, which is the x-coordinate of the vertex. So you look at the vertex, it's the x value. So that's x equals 2.25. Okay, is my vertex, is that the maximum or the minimum? It's the minimum, it's at the very bottom. We do not have a maximum. We have a minimum. And what is the value of our minimum? Exactly, negative 6.125. So this x value gave me the axis of symmetry, and this y value gave me the minimum. The formula for discriminant is b squared minus 4ac. This is the discriminant formula. If your discriminant is greater than 0, you will have 2 real solutions. That means 2 x-intercepts. So here's an example of 2 x-intercepts. I can look at this graph, see that it has 2 x-intercepts, and know that my discriminant must have been greater than 0. Here, on the second graph, I only have 1 x-intercept. That is because my discriminant equals 0. So if your discriminant equals 0, that means you will have 1 x-intercept, 1 real solution. We also call it a double root. Those are different names. Okay, now the final scenario is when your discriminant, b squared minus 4ac, is negative, less than 0. That means you're not going to have any x-intercepts. Notice that our graph never touches or crosses the x-axis. Okay, what it does mean is you're going to have 2 complex conjugate solutions. 2 complex conjugate solutions, that means you're going to have 2 imaginary solutions. And you will not see it on your graph. It will not cross the x-axis. Okay, one thing that I want to point out are these extra bullet points that we have right here. It says if your discriminant is a perfect square. So let's say, for example, the perfect square is 81. What is the square root of 81? 9. So that means when you put this in the quadratic formula, x equals negative b plus or minus square root, your discriminant is right here. That's your discriminant, b squared minus 4ac, all over 2a. So guys, if your discriminant is a perfect square, meaning you know what the square root of it is, you're going to have a pretty number. You're going to have a number like 4, 12, 13. You're going to have good numbers for you to easily graph it on your x-axis. However, if you get a number like square root of 14, what's the square root of 14? Do we know? Without using the calculator to get the exact number, it's going to be something with a whole bunch of decimals, right? That's what we call irrational. Okay, so when it has a whole bunch of numbers behind the decimal, that is irrational. Okay? All right, I'm going to pause here. We're going to do an example. So here's the first example. I'm going to do the very first one on your page. So we have all right, this is our first example. We're going to find the discriminant. So guys, go ahead and find the discriminant. Find it on your own. You can look up here to check and make sure you have it correctly. You guys know what 16 times 9 is? 144. So this will be 0. So my discriminant is 0. What information does that tell me? Yep, that means there's one real solution because my discriminant is 0. I'm going to have one x-intercept. Let's figure out what that x-intercept is. We have to graph this. So guys, my quadratic formula is x equals negative b plus or minus square root all over 2a. Your discriminant will go under that square root symbol. We said the discriminant was 0, so 0 will go under the square root symbol. Your b value is 12, and your a value is 4. Okay, so let's see what this simplifies to. Negative 12 divided by 2 times 4 is 8. Guys, what's negative 12 over 8? Yep, negative 1.5. So guys, that is where your x-intercept is. You only have one x-intercept and it's at negative 1.5 right there. Looking at my original equation, where's my y-intercept? 9, it's your c value. So that's your y-intercept. Right here at 9. Okay, so it's going to look like this. Now, if you wanted to be sure and make sure that this is your vertex, I know it's my vertex because I only have one real solution and it needs to face up. So I know that that's my vertex. However, we can show that as well. So your b value is 12, so we're going to do negative b over 2a. Negative b is negative 12 over 2a would be 8, which is negative 1.5. That's what we just got. Negative 1.25. And if you plug that in, you'll get 0. So the vertex and your x-intercepts are the same in this problem. All right, guys, we're going to do the discriminant for these. So the formula is b squared minus 4ac. This is a, b, and c. So negative 2, we square it, 4ac. What's negative 2 squared? 4 minus, what's 4 times 3 times a negative 1? Negative 12, but what do 2 negatives make? So this is 4 plus 12, which is, okay, so our discriminant is 16. What does that mean?
Too rational.
Too rational. Good. It will be rational. Because when you put this in the quadratic formula, x equals negative b plus or minus square root, and you put the discriminant 16 in there, you guys know what the square root of 16 is. 4. And all over 2a. So guys, this will be 2 rational solutions because you have 16, which is a perfect square. So whenever you get a perfect square, You guys are gonna have two rational solutions. Okay, let's look over here. We're gonna do -5 squared minus 4AC. Let's see what we get. This is 25 minus, what's this? 8. What's 25 minus 8? 17. Is 17 a perfect square? No. So you're gonna have two irrational solutions. Okay? Because if you plug this into the quadratic formula, instead of a perfect 16 like we had, we're plugging in a 17. When you plug this into your calculator, can someone tell me what the square root of 17 is? Plug it into your calculator real quick. Let me know what it is. Ooh, say that again. 4 point. Okay, do you guys see how it keeps going on forever? That's because it's irrational, okay? So when you don't get a perfect square for your discriminant, you're gonna get two irrational numbers, okay? When you get something irrational, just round it. We'll just say 4.12, okay?